Does this series, we'll use n's instead of k's because that's what the book does. N factorial squared over 2n quantity factorial are the terms. That's a sub n. Does this converge or diverge? Oh, both fractions where both the numerator and denominator are getting very big very rapidly. All right, what is factorial? For example, 5 factorial is 5 times 4 times 3 times 2 times 1. That's a definition of what 5 factorial is, which is 120. Don't say 5 to wake up the neighbors. Say 5 factorial. You can say it very calmly. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, 720. 4 factorial would be 4 times 3 times 2 times 1, which is 24. 3 factorial is 6. 2 factorial is 2. 1 factorial is just 1. Anybody know what 0 factorial is? No, it's actually not. It's 1. Why? Because it makes formulas work out nicer. These are all just definitions. I'm serious. That's why 0 factorial is 1, is because it makes formulas work out more nicely in ways we will see for sure next week, maybe even a little on Friday. Factorials do grow fast pretty rapidly. 10 factorial. You could do 10 times 9 times 8 times 7, etc. You can also go to your math menu and go over to PRB for probability and go down to an exclamation point. 10 factorial is 3,628,800. 50 factorial is about 3 times 10 to the 64th power. Probably more than the number of atoms on the Earth. By the time you get to 60 factorial, we might be more than the number of atoms in the observable universe. Oops. 60 factorial. That's close. Somewhere in that ballpark is the number of atoms in the observable universe. These factorials go very big, very rapidly. And here on the top, we're squaring it. Certainly these fractions must be getting really big. This must diverge. No, actually this series converges because the bottom's actually getting a lot bigger, a lot faster. Try when n equals 10. When n equals 10, we got 10 factorial squared. 3.6 million squared is in the trillions. That's about 13 trillion. However, 2 times 10 quantity factorial is 20 factorial is a lot bigger. 20 factorial is on the order of 2 times 10 to the 18th. About 100,000 times bigger. So the ratio is on the order of what would it be? 0.00001 when n is just 10. This is going to converge, but to prove it, you need the ratio test. We need to compute this limit. We'll see that it's less than 1, and that will mean the series converges. If your terms involve negative numbers, you can conclude the series converges absolutely, meaning the series involving just the absolute values of the terms converges. However, our terms are always positive, so we don't have to worry about that. And in fact, even though you should write the absolute value signs, you really don't need them for this example because these terms are positive. What is a sub n plus 1? Replace each n with n plus 1. So you have n plus 1 factorial quantity squared divided by 2 times in parentheses n plus 1 quantity factorial. That's an. Excuse me, that's an plus 1. I'm dividing by an, which means I need to multiply by its reciprocal. So I get a 2n quantity factorial in the numerator and an n factorial quantity squared in the denominator. And even though that looks crazy difficult, it's actually very easy. What you need to use is the fact that, for example, any number factorial like 6 factorial is that number times the preceding number factorial. 6 factorial is the same as 6 times 5 factorial. So n plus 1 quantity factorial is the same as n plus 1 times n factorial. I'm also squaring such a product, so I can square each term, each factor, I should say. This expression, before I take its factorial, is 2n plus 2. That's the same, and I'm doing its factorial, that's the same as 2n plus 2 times 2n plus 1 times 2n quantity factorial. And then stuff cancels. That cancels with that. Another color. This cancels with that. And we're left with the limit of this thing, which is a rational function where the top and the bottom have the same degree. And if you just want extra confirmation, you can expand it out to see that the coefficient of n squared in the top is 1, and the coefficient of n squared in the bottom is 4. You don't really have to expand it out. So this is limit is 1/4, which is less than 1. Therefore, the series, the original series with the summation sign, converges. This sequence converges to 1/4. The key thing is 1/4 is less than 1. Therefore, the series converges. If the limit had been bigger than 1, the series would diverge. And that would in fact happen if I took the reciprocal of these things right away and considered that series. Then this limit would have been 4 instead of 1/4, which is bigger than 1, and the series would have diverged.